Hi, thanks for coming today. I'm Mitch Resnick from the MIT Media Lab, and I'll be talking today about cultivating creativity through coding. And I want to emphasize the creativity, because I think there's nothing more important in today's world than the ability to think and act creatively. I think there's one thing we can all agree upon, is that the world is changing more quickly than ever. So today's children will grow up in a world where they're constantly confronted with a never-ending stream of unknown and uncertain and unpredictable situations. So to thrive in tomorrow's world, they really need the ability to think and act creatively. And too often we don't support them in that. And that's what our research group tries to do, and what we took on as we developed the Scratch programming language and online community, where kids learn to code, but they're also learn to think and act creatively. To give you an understanding, let me share a story of one member of the Scratch community who actually grew up here in San Diego. It's a member of the community named Natalie, who has the username Ipsy, and who started using Scratch in her early teen years. And this video will share the story of how she created with Scratch and what she learned through her creativity.
So I've been drawing basically since preschool when I learned how to hold a crayon. I'm interested in all sorts of art. I started using Scratch when I was 11. I remember the very first project I ever made was a virtual puppy game. But I never thought that I could do like the coding part. Like I thought like, oh, well maybe I can do art, but I'd have to wait till I'm a grown up and like hire someone to code it for me. But then I was like, hey, I can actually do this myself. And I kind of slowly built up my skills from exploring the program and other people's programs, and eventually I made a project, Lemonade Time, where you can kind of walk around and collect items. I got a lot of comments from people, and I thought that that was just the coolest thing and wanted to keep making more. Making art with Scratch is different because I can collaborate with other people, make something interactive that other people can use. Because I'll use it for school projects sometimes, and when people see it, usually their first reaction is like, wow, that's so cool, I wish I could do that, but it's like, you can just like try it.
And Natalie is exactly the type of young person we were hoping to attract with Scratch. Sometimes young people who never imagine themselves being interested in coding, but provide the right possibilities and the right support, enabling them to build on their own interests, in her case, the interest in art, becomes really intrigued with and dives into and develops the skills of programming, and in the process learns many other things. If we take a look at what Natalie is learning through this process, of course, Natalie is learning to think, is learning to reason systematically. As you put together computer programs, you're learning a type of logic that helps in systematic reasoning. But just as important, Natalie is learning to think creatively, to come up with new ideas, express them in new ways, and also how to work collaboratively. As you saw, Natalie was sharing projects in the online community, learning with and from others. By getting this out in the world, we found many young people like Natalie who have a great interest in being able to express themselves with the computer if given the right types of support. We've seen over the last decade, the use of Scratch has grown exponentially. The past year, more than 10 million kids joined the Scratch online community and became official members of the community. Last year, if you look at just everyone who visited the Scratch website, there were more than 200 million unique visitors to the site, and they created more than 100 million projects on the site. But for us, what's most important is not just the numbers, but what it is that they're learning. So we're always focused on how can we help young people everywhere as they learn to code, learn to think creatively, reason systematically, and work collaboratively. So the question is, how can we set up a situation that enables young people to develop these skills, which are important for everyone in today's society? And to do that, we've come up with 4 guiding principles that have guided the design of the technology and the activities around Scratch and around the other work that we do. And we refer to them as the 4 P's of creative learning: projects, passion, peers, and play. Hopefully that stops. So our goal is to make sure that young people, we want to make sure to give them opportunities to work on projects based on their passions in collaboration with peers, in a playful spirit. So let's go through each of those 4 Ps, and hopefully let's take one moment and just see if we can do. Well, any suggestions on the technical side? No. Let me give an example. Let's start with the first P of projects. I'll give an example of the type of projects that kids have worked on in schools with Scratch. Here's one from an elementary school where in a 3rd grade class, all of the kids learned Scratch and then applied it across the curriculum. When they read the book Charlotte's Web, instead of just writing a book report, the kids did Scratch projects about the book. And of course, they were developing language skills, as you see here. But the thing that caught my attention was, notice what happens when the pig moves further away. The pig gets smaller. So the student who worked on this, she was using things she had learned in art class about perspective. If you want something to look further away, you make it look small, you make it smaller. At the same time, how is it that she made it smaller? If you look at the code that she wrote, she took the size and multiplied it by a fraction to make it progressively smaller. So she's learning important mathematical ideas. And that's one of the things we find over and over is that when you give kids the opportunity to work on projects, they learn things across the different disciplines. Now, to us, that seems sort of like a natural way to learn, but in fact, that's not the way most coding is introduced in schools. Typically, kids are given a problem or a puzzle to solve. They get the correct answer. They then can move on to the next problem to solve, move on to the next one. They're learning specific concepts about coding, which can be a useful thing. But what we want to do is to make sure that kids, in addition to learning those concepts of coding, are using it as a foundation for learning many other things. For us, the key issue is not just learning to code, but coding to learn. To give kids the opportunity, once they learn to code, they can learn many other things, as she was doing by learning art ideas and language ideas and mathematics ideas in doing it. We take seriously the analogy to writing. We don't expect everyone to grow up to become a professional writer, but we think everyone should learn to write because it's a way that it helps you organize and express and share your ideas. We see coding the same way. Not everyone will grow up to become a professional programmer or computer scientist. There's great job opportunities if they do, and we hope Scratch will start some people along that path. But we think it's important for everybody, just like learning to write, to help kids learn to organize, express, and share their ideas, to be able to make them feel like a full and active participant in society. The second P is passion. I guess it really doesn't like those white screens. So I think we'll move off of those screens if we can. It does seem to be doing better on the other ones. We'll see. I think one thing we all know is that people, not just kids, but all of us, we're willing to work longer and harder and persist in the face of challenges when we work on things we really care about. But too often, in many educational settings, kids don't get that opportunity. With Scratch, we specifically designed Scratch so that kids can work on a wide range of different types of projects because we know that different kids have different interests and passions, and we want to make sure all of them can work on things they really cared about. Let's see if we can get this up here. So kids have used Scratch to develop everything. Well, I think we're not going to see this. Wide range of different types of projects. So there's a wide range, everything from anime comic strips to virtual construction kits to classic video games to mathematical explorations to science simulations. So kids use it to do a wide range of things based on their interests. Let me give an example. We'll shift over here. Try this. At least for a while. So here's an example. This is the Scratch interface. And this is a game that actually was also here. A young person It was a boy, maybe 12 years old, was doing a game in Scratch. And it was a game like this, where you can control the big fish to eat the little fish. And when I was visiting with him, I visited, actually was in Los Angeles, and I saw he was working on this. And he was very proud of this game, as he should be. But he was also a little bit frustrated, because actually, when I saw him, he had not yet learned how to keep score in the game. So he had so that the fish was swimming around, but he didn't know how to make it keep score. So I showed him there's something that says make variable. If I type in the word score, it automatically generates some new blocks. It's like this one that says change score by 1. As soon as he saw that, he realized that he could use this to then add it into the program. He knew exactly how the program worked, right where the big fish eats the little fish. And then, every time the big fish eats the little fish, the score will go up by 1. And when he saw that this worked, oops, now I have to make it happen. Yes. He saw that it was working, and he reached out his hand to me, and he said, thank you, thank you, thank you. And what went through my mind was, I started wondering, how often do kids thank their teacher for teaching them about variables? And that generally doesn't happen because kids learn about variables in a context they don't really care about. They don't know why they're learning it. They don't know how to put it to meaningful use. But we want to create this environment so that kids go work on things they cared about, because we know they'll both be motivational, but also they'll make deeper connections to the ideas. We've seen that when kids learn about variables in a context like this, where they can put it to meaningful use, they get a deeper understanding and can apply it in other situations. So it's not just a matter of teaching the basics of coding, but doing it in a context where they'll learn the deeper ideas and can apply them in different ways. We'll give this a try again, and let's see. Well, maybe. We'll go on to the third P of peers. And I think one of the problems when people think about learning and education is they're too influenced by images like this, Rodin's famous sculpture, The Thinker. And people imagine that what thinking is about is sitting in deep contemplation. And of course, some thinking does happen in deep contemplation, but that's not where the most creative learning happens. The most creative learning happens in situations like this, where people are working together on projects, learning with and from one another. So as we develop Scratch, we want to avoid, there is this stereotype of that programming is about an individual looking into a screen by themselves. And for us, we want to emphasize the social side of learning, because we know that most creative learning will happen when kids are involved in learning with and from others. So the same time that we launched the Scratch programming language, we launched an online community at exactly the same time. So when kids create a project, they can save it in an online community, and when they put it in the online community, others can then give feedback and suggestions and encouragement. Also, as kids look at what else is on the online community, they get inspiration from others. So the community provides both audience and inspiration. So it serves as a way for kids to continue to learning with and from one another. There's now, the online community has more than 40 million projects, so kids can see this wide range of different projects that they can start to get inspiration from. Let me show an example from the initial video from Ipsy, Natalie. One of the projects that was shown in the video was Lemonade Time. This is the project page in the online community from Lemonade Time. And you can see the project has been viewed 17,000 times. So Ipsy put it up there, and 17,000 people viewed it. Almost 2,000 people said they loved it. Again, very, a real motivation for her to see that people were enjoying the project. 88 people remixed it. So what that means is in Scratch, you can open up the project, as you saw, see the underlying code, and start making changes to it, or changing the characters and the artwork or the music. So everything is open. It's all covered through open standards and Creative Commons licenses. So when kids put things up there, other people can remix it, as 88 people did with this project. And at first, a lot of times, kids will be resistant to this, that they'll see that somebody has changed and made a remix of their project. The first reaction will often be, they stole my ideas, that they're stealing my project. But we then discuss with them about, in Scratch, we're encouraging people to build in each other's work. And when you build in each other's work, it can benefit everyone. If everyone shares, everyone benefits. Now, of course, you have to give credit and acknowledgement. That's part of the rules of the community. Within the community, to be a good citizen, we have community guidelines. So you have to give credit when you're building on someone else's work, but we encourage that. And again, this is not an easy lesson to learn, but it's an important lesson that kids are learning by being part of this online coding community. And it's a hard lesson. I mean, if you think learning to code is hard, learning to share is much more difficult. But it's an important thing for kids to learn, and they do here. And we see that the learning happens much more, there's a much richer learning experience when kids are learning with and from one another in this way. And we see so many different types of sharing. Maybe the biggest surprise to me since we launched Scratch is all the different ways that kids will start collaborating and building on each other's work. Kids will do things, if they want a new character for their project, they'll put out a call and do some crowdsourcing of getting characters from others. Or they'll offer their consulting services for doing music or backgrounds. So it becomes a community where kids are collaborating in all different ways and being creative, not just in their coding, but creative in their collaboration. We can see here also, this is where IPSI was getting comments from others. So about 1,800 people gave comments. And you can tell that IPSI was paying attention to the comments, because if you look at the instructions, it says, edit. Due to popular demand, the otter walks a little faster now. So clearly, IPSI was paying attention to what others in the community were saying, which made a big difference. And that's what we want good designers to do, to be able to put things out there, get feedback from others, and go through an iterative cycle. And this was set up, and she was able to do it that way. The final P is play. I sometimes call this the most misunderstood of the Ps. But when people think of play, they think of laughing and having fun. But for me, play is not just an activity, it's an attitude. It's a way of engaging with the world, where you're constantly trying new things, taking risks, experimenting with things. So let me tell a story about another member of the community from South Africa who goes by the Scratch username Bubble103. And Bubble103 learned to Scratch in school. This is a project that she did in science class about the water cycle. So again, it was a case where she was learning to code and made a simulation of the water cycle, and was both learning about coding and also about the science of the water cycle. But she got interested enough that she started expressing herself in many other ways. She did a game, a fabulous farming game. For social studies class, she did a project about her native South Africa, where she was telling about all the things that she thought were so special about South Africa. So she studied different things and was sharing her pride. One of the most interesting projects she did was, after doing the water cycle, she used about 10 variables, and she found them so useful, she did another project called You Gotta Love Variables. There was a tutorial to let other people know how to do variables. Now, when we created Scratch, we figured that we would make some tutorials, and we figured educators would make tutorials. We never realized that kids would make so many tutorials. But if you look on the website, you'll see literally thousands and thousands of tutorials by kids. Kids want to share what they've learned. And we know that when kids show what they know and share it with others, that's a great learning experience too. The act of teaching others is a great learning experience. And what I really liked about the way Bubble103 shared this project is, these are in the instructions for the project, this is what she wrote. She said, have fun playing around and experimenting with variables and Booleans. The more you experiment and fail, the more you will understand and the easier it will be for you to use variables to make your projects awesome. For me, that's a playful attitude. But I see that as the core of being willing to take risks, try new things. And the most creative activities come when kids are willing to take risks and being willing to fail, but then adapt and revise and make changes. And you can see that Bubble103 was giving this advice, but also took it in her own work. So here's an example of when we interviewed her, this is what she said. She said, because of Scratch, I've become more confident to try new things and express myself. I'm more comfortable with taking risks and making mistakes. Now when something goes wrong, I see it as an opportunity to learn something new. And this is exactly the type of attitude we want for kids growing up to become creative thinkers. If we want kids to be innovative in the world, they need to be willing to take risks, try new things. And we have to create environments where they feel safe taking those risks. In the classroom, kids have to have an environment where if they try something new, that people won't ridicule them if something goes wrong, and we need to do the same things with the online community. We spend a lot of effort to make sure it's an online community that's constructive and supportive. So when kids try new things, others are supportive, even when it goes wrong, so they're willing to take risks like Bubble 103. Now, we're always looking to see how to expand Scratch to make sure that kids' playful engagement can keep expanding in new ways. But the type of technology in the world are continuing to change. We want to make sure that kids can get access to them and experiment, explore, and express themselves with those new technologies. Let me show an example. This is from the latest version of Scratch that just launched a couple months ago. And this new version of Scratch has what are called extensions. So it's made more modular, so you can keep on extending Scratch with new collections of blocks. If I take a look here, you can see there's extensions for, and these are from the Lego company, to if you want to control your Lego Mindstorms robots, your Lego WeDo robots, there's Scratch blocks for doing that. We also have text-to-speech blocks based on some Amazon code for doing text-to-speech, translating based on some Google technology. So we can continue to sort of import new capabilities for kids. We want kids to get access to the latest web services, the latest hardware, but to do it in a way that they can integrate into their own personal projects. So I'll show you an example here that's using the microbit controller that some of you might know. It's a little controller that has different sensors built into it. And here's someone who built a Scratch project that was a flying bicycle. And if we do it, hopefully we'll see it. They built the flying bicycle project, but then out of Lego bricks, luckily with Lego, it can also come back together. We'll see if I can quickly do that. Let's see if it's not. It's OK. I'm going to make it work without putting it all back together. I'm going to take a moment to see if I can rescue this. We'll see. So it did disconnect from the computer, but I think it's going to work. So you won't see it all together, but that's OK. What we're going to try now is, as I then start the project, I can now move this. Did for a moment. Let's try one more time.
Hey.
So as I go, I can control the bicycle handlebars to catch things as they're falling. The balloons. Tacos are more points. So the point is, thank you. So we want to make sure that kids both can build on the screen, but also build in the physical world. Kids are going to be surrounded by different devices in the world that do things automatically. They walk up to a door, it opens automatically. There will be Internet of Things devices around them. We don't want kids just interacting. We want them to be able to build it on their own. For kids to be able to create things like this. To develop as creative thinkers, they need to create. Create is at the root of creativity. We want them to create on the screen, create in the world, and we want to give them the tools so they can both build in both places, create in all parts of their lives in order to develop as creative thinkers. We'll just try. So I just want to end by saying that, I think that our goal is to sort of bring these ideas to all kids around the world, all kids from all backgrounds, all learning styles, all interests, because we think this is important for everyone. If everyone's going to be an active participant in tomorrow's society, they need this. 50 years ago, people started talking about the information society, that information was the raw material that would make a difference in the world. And of course, information is important. But in some ways, we're flooded with information. So 20 or 30 years ago, people started talking about the knowledge society. It's important to turn information to knowledge to make a difference in the world. I prefer to see today's world as the creative society. That what's going to be most important for success and happiness in the future is that ability to think and act creatively. So we need to provide kids the opportunity, if they're going to be full and active participants in this creative society, to give them opportunities to create. Now, I think the best way of doing it is to provide them with tools and activities that support these creative experiences that we've been seeing with Scratch. Now again, I sometimes see myself, as I think about these possibilities, as a short-term pessimist and a long-term optimist. I know it's difficult to make these changes in the world. Educational systems, the way parenting happens, Oftentimes, there's a lot of restrictions that both the mindsets people have. They see learning as just about delivering information. There's structures in schools that are hard to change. So it's difficult to bring about these changes. But I'm a long-term optimist because, first of all, I've seen what happens when kids use systems like Scratch and work on these activities and see their creativity flourish. And I know this is going to be key to the future for them to succeed in the world. So we need to be able to provide these opportunities. It's more than any one organization or team can do, more than any one tool can do. We need to start a movement to make sure we rethink the goals of education so that we put a focus on helping all kids from all backgrounds develop as creative thinkers. We need to build a whole ecosystem of all different people, from educators to policymakers to innovators and industrialists, to all come together to have a new vision of education so we can make sure that kids grow up as creative thinkers so they can be full and active participants in tomorrow's creative society. Thanks a lot.